Guys, I've got another super exciting blockchain tutorial for you today. I'm going to show you how to create a blockchain-based video website just like YouTube. And this is going to be a futuristic, unstoppable Web 3.0 application because it's going to run on top of the Ethereum blockchain and also ipfs. And this is the perfect time to learn this stuff because these technologies are gaining a lot of ground. You know, more and more people are becoming aware that censorship poses a potential problem online. And so I'm going to show you how to build an uncensorable version of YouTube on the blockchain in this tutorial. But don't worry, you don't have to be a programmer already or know anything about blockchain in order to follow along. I'm going to show you everything step by step. I'll show you how to create Ethereum smart contracts with the Solidity programming language, put them on a blockchain, and also create your own front-end website so that people can upload videos to ipfs. I'll show you everything from scratch. All right. So before we get into that, if you're new around here, hey, I'm Gregory, and on this channel, I turn you into a blockchain master. So if that's something that you're interested in, then smash the like button down below for the YouTube algorithm and subscribe to this channel. And if you want to learn how to master blockchain step by step from start to finish, then head on over to dappuniversity.com/bootcamp to get started today. Here's a quick preview of the application that we're going to build together today in this tutorial. This is a blockchain-based video sharing website, a lot like YouTube. So this allows users to upload videos and also watch them and share them inside their browser. But unlike YouTube, this is a censorship-free platform because it runs on the blockchain and also the interplanetary file system ipfs. So whenever someone uploads a video, it will be stored on the blockchain forever and no one can take it down. Let's look at a diagram of how the application will work. So first, let's look at how YouTube works in a really basic sense. So when you use YouTube, you use your web browser and you visit youtube.com. And whenever you visit that website, you talk to a web server, all right? And this web server is where all the code for YouTube lives. And then also the data is stored inside of a database. And all the images are also stored in the cloud right here, okay? So this is a centralized model where basically the creators of the application can do really anything they want to. They can take videos down at any time. They can change how the algorithm works, you know, whatever. But we don't want to build a YouTube clone in a centralized way like this. We want to build it in a decentralized way like this. So let me show you how that works. So first, users will connect to the website, all right, with their web browser, but they'll also use a blockchain wallet to connect to the blockchain, all right? So they'll use their browser, they'll use their blockchain wallet, which will be MetaMask in this case. I'll show you that here in a minute. And they'll connect directly to a website that'll talk to the blockchain, okay? And this is where all the code for the application will live and also the data because it's powered by Ethereum smart contracts, all right? And then these smart contracts will store references to the videos of the platform, which will live on ipfs, the interplanetary file system. This is a decentralized file storage system where you can upload images and upload videos, upload documents, whatever you want to, and they can't be taken down because it runs in a decentralized way, just like a blockchain does. And then that will serve the images back to the user in their web browser like this. And so here's a diagram of how we'll build the application. We'll be the Dapp creator in this case, and we'll create smart contracts with the Truffle framework. We'll publish them to Ganache, our development blockchain, all right? And then we'll use MetaMask to connect to our website that we'll create in React.js. All right, we'll show you that here in a minute. And then we'll run the Dapp, and whenever we interact with the blockchain, we'll be able to talk directly to Ganache with MetaMask, and we'll also code the client-side application in React, which will also talk to ipfs. So this might look kind of complicated, and you can pause the video at this point to, you know, study this diagram, but all of this will be much more clear once we build the application. And then I recommend going back and looking at this diagram once you've finished the project to get a higher level understanding. Now let's install the dependencies we need for this tutorial. The first dependency is Node.js. This is going to allow us to install all the packages on our computer as well as run our client-side application. So you can see if you have Node already installed by going to your terminal and typing node-v. So I'm using Node 9.10.0. I would recommend using the exact same version for best results during this tutorial, but you can probably use the latest version if you really want to and you know what you're doing. So you can download Node directly from the website, or you can use a command line tool like Homebrew, a package manager to install it that way. The next dependency is the Truffle framework. This is a framework for creating Ethereum smart contracts. We can write Ethereum smart contracts with the Solidity programming language, write tests against them, and deploy them to a blockchain with Truffle, as well as many other things, which you'll see in this tutorial. You can install Truffle from your command line like this, say npm install -g truffle at version 5.1.39. The next dependency is the Ganache personal blockchain. This is a blockchain that will run on our computer. We can simply download it and run transactions in the blockchain, deploy smart contracts to it without having to pay any real money. So go ahead and download Ganache. You can just click the version for your operating system here. And whenever it's finished downloading, you can open it and you'll see that you have a brand new blockchain running on your computer just like this. You'll see lots of different accounts funded with 100 fake Ether. And don't get too excited because this isn't actually worth anything. The last dependency is the MetaMask extension for Google Chrome. Most modern web browsers won't connect to the blockchain out of the box, and so we need to install a special browser extension to do that. That's exactly what MetaMask does. It's an Ethereum wallet that turns our browser into a blockchain browser. So go to the Google Chrome Web Store, find MetaMask, and click install. And once you have it installed, you should see a Fox icon in the top right-hand corner. And just walk through the setup steps to get that started. Now let's start coding the project. So head on over to the link down in the description below. This is going to be the GitHub repository for the final code solution. All right, you can see the project diagram listed here, as well as all the code. Okay, so you can download this if you want to. If you're not familiar with Git, you can download a zip file. But I'm going to use Git, and I'm going to clone a specific branch. So you can see that there's a starter code branch here, and that's what I'm going to choose. So copy this link from your browser like this, then go to your terminal and say git clone -b, all right, starter _code, and then paste in the URL here, and that'll create the project. All right. So now I'll enter into the newly created directory like this, cd d video. All right. And then here we go. So now I'm going to open this in my text editor. I'm going to use Sublime Text. You can use whatever text editor you like. So that Sublime Text command that I have, subl dot, is just a shortcut that I have configured on my computer. That's okay if you can't do it. You can just open it manually in your text editor from the file browser if you want to. So now I'm going to take a quick tour of everything inside this application. So we have the basics here. We have a truffle-config file. This is where we configure our truffle project to connect it to the blockchain. So in this case, we are connected to Ganache. So make sure that you have Ganache open. This is our development blockchain that has, 10 accounts, all with, 100 fake Ether credited to their accounts like this. Okay. So, what you can do is, configure your project to connect to any blockchain you want to. Here, I also have it connected to a test network. But for now, we're just going to use the Ganache connection right here. Okay. So next, we'll take a quick tour of the source directory and the contracts directory. All right. So this is where we have the basic smart contract for the D-video contract. This is going to be the contract that governs the application, where we can basically upload videos and we can store them on ipfs. Okay. So in this case, like I said, we've got some of the code sketched out here already, but we'll fill this in throughout the tutorial. This is just to get us started really fast, so we don't have to build everything out from scratch, okay? So if this is your first smart contract that you've ever created, then what you're looking at is the Solidity programming language. So this is the main programming language for writing Ethereum smart contracts. It looks a lot like JavaScript. So if you've written JavaScript before, then this should look familiar to you, okay? So here we just have the contract keyword for D-video. That's the name of the smart contract. And then we put all the code for the smart contract inside these curly braces. You've got the Solidity programming language version at the top, 0.5.0. And then you can see some basics inside of here. So at the very top, this is a variable. Okay, we'll start with this one. This is a variable name. It's just the name of the smart contract. It's a string, so we call it D-video, okay? And this state variable, the value is actually written to the blockchain, so it's stored forever. And of course, Solidity is a statically typed programming language, so we have to say string here. That's the type of variable, and this data type can't change, all right? And we call it public. Which means that we can access this value name outside of the smart contract. And we'll do that inside the JavaScript console here in a second, just to show you how that works. Okay. And then of course we have some functions inside of here, but we'll get back to that in a minute. Okay. Let's just go ahead and, set this up, boot it up in the console so we can see that the project's actually connected to the blockchain, that it works. Okay. So now that we have this basic smart contract, we also need a migration file that puts the smart contract on the blockchain. And that's what you see over here. So if you go to the migrations directory, you'll see this initial migration. This comes by default in Truffle projects. But I've also created a migration to put the dvideo smart contract on the blockchain. So we just say dvideo equals this right here. And then we deploy the dvideo contract to the blockchain like this. Okay. So let's go ahead and do that. Go to our terminal and say truffle migrate. And this will put the existing dvideo smart contract on the blockchain. All right, so it looks like I had a little problem here. I haven't installed the node packages yet, so that really should have been the first step. So we'll go ahead and install the node modules like this. We'll say npm install, and we'll wait for that to finish. All right, so now that's finished, and what we want to do is put it on the blockchain. But before I do that, I just want to make a quick note. You might see some warnings here. This is pretty verbose. It's not ideal, but that's just sort of the state of the libraries and dependencies of this state in the game. So don't worry about those. As long as you see the success message here, everything worked. So we can clear that. And now we can say truffle migrate. All right, this will put the smart contract on the blockchain. I'll wait for this to finish. All right, so it's compiling the contracts, and then it's starting the migrations, and then boom, there you go. So you can see here, the initial migration happened, and then the deploy contracts migration happened. You can see that here. And also these are numbered. So, this tells Truffle which order to run them in. So initial migrations is first, deploy contracts is second. All right, and you can see that reflected here. Okay. So let's go ahead and boot up the console like this, say Truffle console. And this will give us access to a JavaScript runtime environment that we can talk to the blockchain with. We can write commands in JavaScript inside this console and interact with the smart contracts, interact with the blockchain, do whatever. So we'll just check our smart contract like this. We'll say dvideo equals await dvideo dot deployed. I think that's the right name. Let's just see. All right. And you might see undefined here. That's okay. That's just the console output. That's not the actual return value. So we'll just say dvideo. And then boom, there you go. Here's the JavaScript version of the smart contract. So we can access the name like this. So you'll see the smart contract name, dvideo name. All right. So we'll say name equals await dvideo. Or sorry, dvideo that name. Okay, it says undefined. That's okay. Again, that's just the console log value. That's not the actual return value. So name. And then boom, there we go. dvideo. So that's how we talk to the smart contract inside the console. That's how you can access this public state variable here. So again, this is a variable value that's written to the blockchain with this smart contract, and we can fetch the return value because it's public. All right, it's accessible outside the smart contract, and it's a string, and the name is dvideo, which we can see that here. So now before we continue coding out the smart contract, let's revisit the diagram of how the application is going to work. So, like I said, we're going to use our front end, our web browser to connect to an Ethereum wallet. It's going to be MetaMask in this case, to talk to the blockchain. All right. And that's where this smart contract is going to live that we're coding. All right. And what this smart contract is going to do is going to do a few different things. So it's going to store videos. It's going to list videos. And it's also going to let us upload videos. And maybe there's a better order of that. Maybe it's, 1 is upload videos. So 1 would be upload videos, 2 store videos, and 3 list all the videos. Okay. So basically, whenever we upload the video, what's going to happen is we're going to upload it directly to ipfs. Okay. That's the interplanetary file system. All right. And how ipfs works is it gives us a hash. Okay. And then we're going to store this hash back on the smart contract whenever we upload the video. Okay. And it's going to store that hash on the blockchain. Okay. And then we can access all the videos that we've created when we list the videos like this. So let me show you a quick example of what that looks like. So at the end of the day, whenever you upload, a video to ipfs, you'll get a hash that looks like this. All right. So you see this big old hash right here. That's basically the ID of the file on ipfs. Okay. And then you can access it from the ipfs gateway like this. So ipfs.infura.io/ipfs, and then you give it the hash. So here's an example video. This is actually running on the ipfs network. Okay. This is a test video that we'll upload later when we create the project. But essentially what we want to do is kind of do this handoff where we upload that file to ipfs. It returns this hash right here. This will be the location of the video. And we'll store the location of the video inside the smart contract. That's when we store the videos right here. And then we can list all the videos that are saved from the on ipfs with this smart contract as well. So that's going to be the entire responsibility. So back to the code. So basically we need three things. We need to store the video with the ipfs hash. That's what this upload video function does. We give it the video hash from ipfs. We give it the video title. So that's going to be the functionality that we'll create later. We need to actually save that video on the blockchain. So we'll create a way to do that inside of our smart contract. And we also need a way to model the video. So those steps will be 1, model the video. Okay. And then we'll say, store the video. All right. And then upload video. And then for list video. Okay. List all videos. So let's start with number 1, how we model the video. So we're going to do this inside Solidity with something called a struct. All right, so that's going to be this step right here. So we'll go ahead and model the video. Model the video. So Solidity allows us to define our own custom data types with structs. So we can say struct video like this. All right. So this will be something we just make up out of nowhere. That's what structs allow us to do. We'll create a video object. And inside of here, we say uint ID. So this will be the unique identifier for the video inside of our smart contract. This is an unsigned integer. This is just a number with no negative sign. That's what unsigned means. All right. And then string will be the hash of the video. This will be the location on ipfs. Okay. That'll be this thing right here. This hash. Okay. And then we'll have the title. This will be the title that we create, just like YouTube has. And then we'll say the address of the author. This will be the person who uploads the videos. This will be the Ethereum address, the person, their wallet address as they're connected to the blockchain. It's like their username on the blockchain. So we'll save that. All right. So that's how we model the video. That's step number 1. Okay. So because we've created a way to do this, we haven't actually stored any videos in the blockchain yet. So let's go ahead and say that's done. So now we want to store the video. And we're going to do this something called a mapping inside of Solidity. So a mapping is another data structure that we're going to store here. We can create one just like this. So we'll say mapping uint video public videos. Okay. So a mapping inside of Solidity is just a key value store. It's kind of like how a database works. We can give it a key and a value. So in this case, the data type of the key is an unsigned integer. So it's just a number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way up until, a really big number. And then the return value is going to be this video struct that we just created here. Okay. And we'll call this public videos. Okay. So, basically that crosses off this responsibility. So store the video. That's what we do here. Whenever we put a video inside this mapping with an ID, then it's going to write it to the blockchain. That'll store it. Okay. And then that's also going to give us the ability to list the videos because this mapping is public. So it's going to give us a function called videos that we can call, pass in the ID, and fetch out each individual video. Okay. So you can see that here. Just like we have this video name, all right, it returns the name, D video. We can call videos, pass in an ID, and get back a video struct, just like we got back this D video string. We can get back a video with all the data, like the ID, the hash, the title, and the author. Okay. So that crosses off both of those responsibilities. And then now we want to upload the video. Okay. And that's what this function is going to do right here. So this is just a function inside of Solidity with the function keyword called upload video. We just create this name. It takes 2 arguments, a string, all right, the video hash. That's going to be this hash here from ipfs, all right, and then an arbitrary title. that we create whenever we upload the video. All right. So, whenever we do that, we'll just add a new video to the mapping like this. Okay. So we'll create a new video like this and we'll put it inside this videos mapping. So I'll show you how that works. So we'll say, let me bump up the font a little bit here so you can see. So I'll add the video to the contract like this. We'll say videos, and then we'll use these brackets and we'll say, we'll call it the ID. Let's just say uint ID equals 1. We'll just hard code this for now. You'll see how this works in a minute. So ID. Basically, we're going to store the video based on the ID inside the mapping like this. Videos video ID equals video, and then we'll pass in the ID, the video hash, the title, and then the author, which in this case is going to be msg.sender. So I'll explain all that here in a second. But this is how we store a video onto the blockchain. So what do we do here? Well, first of all, we created a new video struct. So this right here, a video. That's how we do it. Whenever we create a new one, we just call the struct name, in capitals like this, and we use these parentheses. All right. Then we pass in all the arguments needed to create a new struct. So we defined those here: an ID, which is an unsigned integer, a string of the hash, string of the title, and then the address of the author. So here's the ID, which we've just hard coded for now. We'll change this in a second. The video hash, which comes from here, the title, which comes from here. All right. And then this thing called msg.sender, which is the address of the person calling the function. So, let me explain how that works. So basically, Solidity has a global variable inside of the smart contract called MSG or message, and that has a lot of different attributes. So one of them is the person calling the function, so message sender. That's the address, Ethereum address of the person who is uploading the video in this case. Okay. So we created a video struct, and then we save it inside the videos mapping here like this. So we just say videos, pass in the ID, and then it's going to be equal to this new video. Okay. So now let's actually update this to have a real ID. So we're going to use a counter cache for this. All right. And that's what this is here. So this video count at the top, this is just a variable that stores the number of videos that have ever been created. All right. So whenever we create the smart contract, it'll be 0, but we can change this value inside the function like this. Basically, we'll just say videos count or video count. Anytime the function is called, we could say, equals video count plus 1. All right, we could do that. And then pass in video count here. All right. So that's how we create the ID. So basically every time we just take the existing video count, we add 1 to it, and we use that as the ID here. Okay. But there's a shortcut inside Solidity where we can just say video count plus plus. All right. And that's a shortcut for just adding 1 to the existing video count. It just increments it by 1. Okay. So we'll say video count is this. All right. Pass it in. Boom. Done. All right. And then that's what we use this video count for. It keeps track of all the videos. It's basically our ID management system. And then we save it inside the videos mapping, which acts like our database like this. And we create a new video with all the required arguments. All right. And so really that's the basic functionality of the entire smart contract. We could just leave it like this and it would work. But we want to add some additional features to this to make it more robust. Okay. So the first thing we want to do is create an event that allows us to know when the video was uploaded. So we can create events inside Solidity like this. All right. We can just do this. All right. And use the keyword event and say video uploaded. And we pass in the same arguments as the struct. So we just say the ID, the hash, the title, and the author. And this is going to allow us to subscribe to this event whenever it's triggered from our application. Okay. So we can trigger the upload event just like this at the bottom. basically just do this, boom. We use the emit keyword and just say video uploaded. All right, it's the same name as the event. And we just pass in the arguments, the video count, the video hash, the title, and then message sender. All right. So next what we want to do is add some requirements to the function to make sure that it's more robust. So right now someone could call this function and with an empty video hash, or maybe and that would not be good. So we want to make sure that it's present, that it exists. So we can do something, we can do like that, like this. We can use Solidity's require function, require. And what this function does is it checks that a set of parameters are true before the rest of this function executes. So you can basically say require true. And if I just left this here, then this would be fine and the function would always execute, okay? But if I said require false, then none of this code down here would ever run. It would just throw an exception, it would blow up, and this wouldn't work, okay? So we can basically pass expressions inside of here that evaluate to true or false. And if the expressions evaluate to true, then the function will continue running. And if they evaluate to false, then it'll halt execution, it'll blow up, all that kind of stuff. So this is basically a way of just adding a set of criteria that must be met in order for the function call to occur. So we're going to add some of those criteria here. And the first one is to make sure that the video hash exists. So this video hash. So what we can do is take the video hash and convert it to a bytes. Say bytes, and then just say length is greater than 0. Okay. All right. So basically what that does is it ensures that this string has a length that's greater than 0. All right. That effectively means that the video hash exists. We can do the same thing for the title. All right. Make sure that the title exists. So I'll take this title and do the exact same thing like this. All right. And then we will also make sure that the uploader's address is not from an empty address like this. So boom, message sender display equal the empty address. Okay. So that is the complete smart contract code. So it's pretty simple. It models the video. It stores the video. Stores the ipfs hash of the video. We can upload the videos with that new function. And then we can list the videos, okay? So at this point, what we want to do is show you the tests, okay? So I'm a little short on time today, so I don't have time to code out all of the tests for this smart contract step by step, but I'll just leave them in the code solution so that you can see how they work. You can read through them. You can check out any of the other videos that I've done on my channel that show you how to code the tests step by step, or if you want to learn testing in depth, of course, you can do that inside the Blockchain Bootcamp. And so if you go to the test folder here, you'll see all the requirements for the video, the D video contract. So this is a test written in Mocha and Chai, which are bundled with the Truffle framework. And they're just tests written in JavaScript that, check that the D video contract works the way we think it does. So you can see the tests here. So say describe deployment, and we just make sure that the deployment happens and that it has a name. Just like this is basically everything we did in the console. And then next we check the behavior of the video contract. So this is where we basically say that it creates a video. We test the upload video function. Okay, so we upload the video with the hash. You can see a test ipfs hash here. All right, so video title from the author. All right. And then we also say that it lists videos, and this shows us how we, dig into that contract. We call the videos function. We pass in the ID, and we check all the arguments of the hash the struct that's returned. Okay. So I'm going to save this. I'll show you how to run the tests. So we'll exit this, and we'll say truffle test. And hopefully it'll pass as long as we didn't make any coding errors when we created the contract. So let's see. All right, boom, there we go. So they all work. It deploys successfully, has a name, it creates videos and lists videos. So at this point, if you want to go back and look through those tests, code them out from scratch, you can do that yourself. But what I'm going to do now is go ahead and put this smart contract on the blockchain so that we can create the client-side website. So I'm going to say truffle migrate. I'm going to use the reset flag, -- reset. And so what this does is it puts a new copy of the smart contract on the blockchain. So remember, smart contract code is immutable. It can't change. And so if you want to update the smart contract code, the only thing we can do is deploy a new copy of it. All right. And that's exactly what the reset flag does whenever we run truffle migrate with the reset like that. Okay. So boom, there we go. We've got a new copy of the smart contract on the blockchain. Yeah, awesome. So we're good to go. So now what we want to do is switch over to building out the client side portion of this application. Now let's start coding out the client side portion of the application. All right. So the first thing we want to do is go ahead and open up a new terminal tab here. And we want to start the web development server. Sorry. So let's go ahead and do that like this. Say npm run start. And that's going to boot up the React application that we have inside of our project. All right. So if you go here, let's see. Sorry, this is my old copy. You should see a new browser window pop up for you. You won't see this just yet because that's my old version. Wait for this to refresh. Oh, waiting. Sometimes this takes a second. We can go see what's going on here inside the terminal. You can see this waiting message. All right, cool. Awesome. So yeah, this is exactly what you should see. This is the cleared out starter template. So you can see D video up here. It's the name of our project. You can see the blank Ethereum address here and then an empty canvas. And this is the empty canvas that we'll use to create the project. So if you go back to the text editor, you can see the source code for all this. Go to the source directory and then find the components directory, and you can see this app.js file. Okay, so this is the main file for the application. This is a React component. So let me go ahead and explain that. If you're not familiar, React is a JavaScript library for building user interfaces. Okay, so basically it allows us to code websites with JavaScript with something called React components. They're basically just a way of organizing our code like this. Basically, we have these classes and you give it a component name, and it allows us to write JavaScript and HTML code all in one place. All right. And so we can create components, we can organize our code this way, we can reuse them. And then it also gives us something called the state object, and that allows us to basically store data inside of our client-side application. So an example of React state is this to-do list here. So you can see the to-do list, like what needs to be done. You can say item 1, right? And then add item 1 and then item 2. Okay. So how does React know what items are on this to-do list? Well, that's what the state object is for. So you can see it here. Basically, the state is equal to this, and it keeps track of items inside of an array right here. Okay. And so that's exactly the two main benefits we're going to get from React. The components, which will allow us to write our code with JavaScript and HTML, and then the state object that will create a front-end database where we can put all the blockchain-based data inside of the JavaScript front-end app, okay? So don't worry if you're not a React expert. You can pretty much catch on just by following along with the tutorial. But if you are an experienced developer and you want to check out React, then I highly recommend it because it's used pretty heavily in the blockchain space, particularly with Ethereum. So if you open up this app.js file, it's got some basic code already laid out for us so we can get started fast. Because again, I'm moving a little faster today than I normally am. And we're going to fill in all this code to wire up the application. But I'll call out the important parts as we go along here. So we can see that this render function here is what lays out all the code on the page. And it's got several main parts. You can see this nav bar here. All right, that's a component here. The nav bar, okay. And if you go to the page, then you can see the, let's see here, let's find it. Put it over here, the nav bar here. So D video and the Ethereum address. All right, go to the nav bar. You can see the D video, All right. And then the Ethereum address here. Okay. And so we'll fill that information in. All right. And then the nav bar is inside of here. Here's where the nav bar is rendered on the page. And then the nav bar is imported to the top just like this. All right. So yeah, you can see that. Then the content on the page is here. So main. All right. And then main is where we have all the code for the video like this. All right, so let's go ahead. And the first thing we want to do is connect the application to the blockchain. So let me explain. Out of the box, there are a few different things we need to do. Out of the box, basically, like your web browser does not connect to the blockchain natively. So that's what MetaMask is for. You can use MetaMask to connect to the blockchains. The first thing you want to do is open MetaMask and select the Ganache network. Okay, so you can go to custom RPC, paste in the RPC URL. So go to Ganache and then, copy this. Let's find it. All right. And then say RPC URL. Okay. So this already exists for me. You can call it Ganache if you want to. I've already done this, so it's telling me it already exists, but you can just click save. And once you do, you'll see, Ganache listed here in your networks. All right, click Ganache. And that's going to allow your web browser to connect to the blockchain. So what you want to do also is import your account because you need a username on the blockchain. That's basically what the account is. So you do that with your private key. So the private key is kind of like your password if the username is like your address. So I'm just going to show the private key here. Normally you wouldn't do this because private keys is sensitive data. So, never do this for real, and highly recommend you never use this account in real life because everyone who's watched this video has seen it. So you can just copy it like this. All right, click done. Go to MetaMask and import the account. So we'll just say import account, private key, paste it in, click import. So I've already done it. So it's going to tell me that it's a duplicate. But when you do it, you'll see your account listed here. You can give it a name if you want to. I have, or you can just leave it as the name that MetaMask gives you. So now we've connected our web browser to the blockchain with MetaMask. The next thing we need to do is connect our application to the blockchain. And that's exactly what Web3.js is going to do. So Web3.js is an Ethereum library for talking to Ethereum. That's the blockchain that we're going to use in this tutorial. And Web3 can just be imported into our project really simply and easily, and we can connect it to the blockchain in just a few lines of code. So let me show you that inside the application. That's what we've done here. So we say import Web3 from Web3. All right. And then now we can use this Web3 import to instantiate a connection to the blockchain. That's what we do here. So one of the reasons I have this hard coded already into the starter code is that these are the exact instructions that MetaMask gives us to connect our application to the blockchain. So I don't personally even write this code myself. Whenever I create decentralized applications, I basically just copy and paste this every single time. So that's why it's already done for you here. You don't even have to understand how this works completely. Just know that it basically takes the Ethereum provider from MetaMask and injects it into your application. And so we call this function here inside this component will mount. This is just a lifecycle callback inside of React. So we say load Web3. And the next thing we want to do is load the blockchain data. And that's exactly what we do inside of here. So a lot of the heavy lifting for you is done. I want to get to the important part since I'm a little short on time today, which is this function here. This is what actually takes all the information in from the blockchain and puts it into our application. This is the really important part. Okay. Everything else is kind of, rinse and repeat. And we'll get all that, as we go along. So let's just, let's go ahead and fetch our account out of MetaMask and show it on the page so that we can see that, the application's working properly and that we've actually connected to the blockchain. So we'll do that like this. Basically we'll say, we'll use Web3's get accounts function. So you can see that inside the Web3 documentation here. So you can say Web3 ETH, and we'll say get accounts. So this is exactly how you do it. So Web3 has .eth. You can do Web3.eth and then get accounts. All right, and that'll show you all the accounts from your wallet, which will be MetaMask in this case. Okay, so I'm going to do that inside this function right here. So we'll load accounts. So we'll say const accounts equals await web3.eth.get accounts. All right, so we'll save that, and then we'll console.log accounts. All right, so we'll save that. We'll go to the terminal, and then we'll open up the console here. All right, I just did that. You could do inspect element if you want to. Inspect, and then go to console, and you can see that information here. So here you go. You can see this array is logged here, and we'll open that up, and then boom, there you go. There's our address from MetaMask. So that's the exact same address that we see here, to AEC and then to AEC. Awesome. So we have connected our application to the blockchain. We've connected MetaMask to the application as well. So the web browser is talking to the blockchain, and the application is also talking to the blockchain. So that's huge progress. Okay, boom. So now what we want to do is actually save this account and store it on the page. Okay, we want to basically populate this address right here with the account. So we'll do it like this. We'll use the React state object that I showed you earlier. Basically, we'll use this state object that we add the to-do items with, but we'll store a lot of other data like the account, the smart contracts, all of the videos for the application. We'll store it inside this state object, a lot like this to-do list. So let's go ahead and load up the account like this. We'll say this set state. This is how we add new accounts to the state object inside of React. Say account, and we'll say accounts. We'll pass in 0. So accounts is an array here. I mean, it's a 0-based index array, which basically means you start off with 0, 1, 2, 3, etc., instead of starting from 1. So we can get the first item out of the accounts array by saying accounts and then passing in 0 here. Okay, and then we're gonna store that inside the state object. So let's look at the state here. We can basically set the default account like this, and say account goes 0x0, but we're going to update this to be our actual account. Okay, so here's the constructor, just like the React example, and then that's inside of our project, and we're setting the default state. This case will be 0x0, but this will change to our MetaMask account whenever we do set state account here. All right, and so we could even prove that and say, well, we'll prove it here in a second. Okay, so save it. Just go refresh the page, make sure everything's working. It's not broken. All right, nothing's changed. That's okay. So now what we're going to do is pass this value down to the navbar. So you can see this app.js component is the main component for the application. But we have this navbar component that's actually going to render out the account here. So we can just pass it down pretty simply like this. We just say account equals this.state.account. All right. So we set items to the state like this set state account, and then we fetch it back out of the state like this. So this.state account. All right. And then inside the navbar file, we go inside of here and we add the account here. So we say this.props.account. Okay, so it's different. We did this state.account here, but what that does is it passes it to the navbar's props or properties. Okay, so this.props.account is going to be the value that's accessible inside of the navbar. So account has properties. Navbar has properties. Account is one of them. And then inside of here, we should do this.props.account, which is inside of here. Okay. Oops. All right. There we go. Boom. So now we can go back to the page here and then click boom. And then there we go. We can see it. Now it's not totally correct because we still do see this 0x0 off in the corner. Let's change that. Go back to the navbar and then do this. All right. All right. Like this. Let me just make sure that's right. All right. Yeah, boom. Awesome. All right, so now that's working. All right, so we're able to fetch the account from MetaMask, put it on the page. Next thing we're going to do is actually add an identicon. So that's the fancy user avatar. And we'll do that like this. We'll use the identicon library. I'm just going to paste in this code from the final code solution like this. Okay. So basically, if the account prop exists, then we're going to add this image. Okay. So this is the identicon image. This comes from the identicon library, which you can see in the package.json file here. So package.json, this identicon library. Okay. And it's going to automatically generate a fancy user icon for this application. All right. So we got a little bit of an issue here. Let's just fix this. Go back in here. And then let's just do this. All right, save it. All right, so let me just figure out what's going on here. All right, so I just fixed it. So it's working now. So let me show you what I did so you can do the same thing. So go back to your code. And in the default state, set your account to an empty string. So don't use 0x0 because that will cause the identicon library to blow up. Sorry, it's my fault. So just set it to empty string and go back here and yeah, boom, there you go. So you can see the automatic user generated avatar here. Yeah, it's pretty nice. So let's continue on here. Now that we've connected our application to the blockchain, let's do a lot more. So next thing we want to do is actually fetch the smart contract, the dvideo contract, and put it in this application. So you can see we've imported the dvideo ABI file up here at the top. Really, this is a truffle artifact. So you can see this, see here, source contracts. Actually, it's source ABI is my fault. Look at this dvideo file. It's got all the information that we need in order to create a JavaScript version of this smart contract. So let me show you how that works. So inside Web3, let's go back here. Web3 ETH contract. Web3 is going to allow us to create a JavaScript version of the contract so we can call the functions on it and pull the data in from the application and upload videos. So we can see that we create a new Web3 contract like this. We say new Web3 ETH contract, and then we pass in two pieces of information. The ABI, which is the JSON interface, and then the address. So the ABI is just a JSON description of how the smart contract works, all the functions. And then the address is just the location of the smart contract on the blockchain, right? So like whenever we deployed it, we got back an address, which you can see here. You can see here. You can also see the address like this. You can say Truffle Networks. And it'll list the addresses here. Okay. So boom, there you go. I'll clear that out. And then let's see here. Go back to the code and let's go ahead and use that. Let's just copy this from Web3 like this. And we can do it here. Okay, so let's do it like this. Basically, we'll want to do this part. So we'll do this here. Okay. But we need all this information. So let's get the JSON interface first. So we do that from this file. So this dvideo file has the ABI. So that's the ABI here. So basically we can just say, let's see here. Got dvideo at the top. So we can say dvideo, just copy this. For the ABI, we can just replace this and say dvideo.abi. And then now we want the address. Okay, so dvideo. We can't just say dvideo address here because the address changes depending on which network you're connected to. So if you look at networks, you can see the different networks that are deployed here. Okay. So you can see like 5777 is the network that we're connected to with Ganache. You can see that here. All right, 5777. And this has the location of the address right here. Boom. So basically what we have to do is say like dvideo, and then pass in the net, like this, sorry, dvideo.networks, and then pass in the network address, which is like, 5777.address, okay? And that would create a copy of the smart contract that we can call the functions on. But the problem is we want this to be able to change and be dynamic whenever we change addresses in MetaMask. So we need to actually fetch the network back from Web3 like this. So we can say, let me show you. So Web3 ETH.net. Let's see here. Get ID. Let's see here. .net. Let's try this. Hold on. For some reason, I don't see the. See here. Get ID. I don't see it in the documentation for some reason. That's okay. I'm probably just in the wrong place. What we can do is basically say this. We can get the network ID like this and say const network ID equals await web3 eth.net get ID. All right, and that'll give us the current network that we're connected to. And then we can pass it into networks here to get back the address required for the smart contract. So we can say network ID and then boom. And that will give us a copy of the smart contract. So the next thing that we want to do is only do this if the network ID exists, okay? So we'll say get the network ID, all right? And then basically say const network data. This is the network specific data inside of here. So, oops, sorry. So networks, all this specific data in here. Okay. Basically, we'll store that to a variable like this. dvideo networks. Oops, sorry. And then pass in network ID. Okay. And then that's going to be the network data. And then we'll say basically if network data. Okay. Then we'll pass in, then we'll do this whole thing. Okay. But then we'll just say, we'll do like this and we'll assign it to a variable. We'll say, oops, sorry. Say boom. So const dvideo equals web3 eth contract dvideo ABI and then network data address. Okay, so that breaks that up so it's better code. And it'll only run if the networking data exists. Okay, and if it doesn't, all right, then basically we just want to say, boom, the contract has not been deployed to the detected network, and we want to, show that. Okay, we can console log. dvideo here. All right. So go back to the thing. All right. So dvideo is not defined. That's okay. Let's just fix that. Basically, we just need to change that to lowercase. Let's see here. Sorry, uppercase. So these three, sorry, let's try that. All right, boom, there we go. Awesome. So now we can see the contract is logged to the console here. And if we change networks and like go to the main Ethereum network, we just say, let's see here, main, refresh the page, and boom. So dvideo contract is not deployed to the detected network. That's awesome. So that's working properly. So now we can say, here, and go back, and the error goes away, and we can see the contract in the console. Awesome. So we have imported the smart contract into the project. So now we want to do is set the state here. So instead of console logging, we're going to say this set state dvideo, and let's go ahead and update the default state to handle all the future things we're going to write to it. Okay. So we're going to store the account, the dvideo, the videos, loading, current hash, title, all that kind of stuff. Okay. So next we want to do is import all the other data from the smart contract like this. We'll go up here and we'll say First thing we'll do is fetch the videos count from the video. And tell you what, we're just going to go ahead and code all this out pretty quickly. So we'll say here, dvideo. I'm just going to do this faster because now you've seen the basics, and then we'll do this. So boom. So I'm going to add some video. I'm going to add some space so we can explain all this. So what we do now is fetch the videos. So we do that first by taking the videos count. So we say await dvideo methods video count call. So that's how you do it in Web3. I'll show you right here. So let's see here, Web3 ETH contract, and we can see my methods call. So anytime you read data from the blockchain, you have to actually say call after the method name in order to get the value. So you can't just say video count, all right? Because that won't return the actual value. You have to say video count.call, okay? And that's going to return the videos count, which is going to be, 0 in this case because we haven't uploaded any. But as we, add videos, this value will increase by 1 every time, all right? So we save that to the state. And then next we load the videos and then sort by the newest. So we use a for loop in JavaScript here. So we start with the videos count and then we add 1 each time, okay? And we say video methods, videos, we pass in the I, it's for the index or the ID, we say call. And then every single video, we add it to the state like this, all right? And then last what we do is basically set the latest video as the preview, okay? And you'll see how that works here in a minute. And then we set the loading state to false, okay? So this is all the code that we need in order to fetch all the content from the blockchain. So this just hydrates the application with data. It takes all the videos from the blockchain, puts them into the application, loads the video count, it sorts the videos and puts them in the app, and it adds the latest video to the video player, which we'll hardwire that up here in a second, okay? Save that, go back to page, make sure nothing's broken. All right, boom, done. All right, so now let's add the ability to upload a video, all right? So first what we're going to do is basically, let's see here. We want to, I'm trying to think of the best way to do this. Let's go ahead and go to the main component, okay? And show this content on the page. We're going to show the upload video form, and then we'll actually capture a file, and then we'll lay the content on the page like that, okay? So inside this main component, what we want to do is create this form for uploading the video. So what we'll do is just fill in all these sections one by one. Okay, so we'll start off with this. We'll just remove this commented out part here. All right, we'll just do this. This will show the video. So let's say share video. Okay, this should be the text for that section. Click save. All right, go back here. We see the share video pop up. So this is where the form is going to go to put the video. All right. So we can go ahead and take out some of that. So we'll say right here, we'll add the input first. Okay. So we'll add the upload button so you can see that on the page. We'll just put that in here like this. This is from the final code solution. All right. So this will be a submit button, so we can save this and go back to the page and see that here. So you share video and then upload. All right. And then next we can create an input. All right. So we'll do that like this. We'll just say input. Save that. All right. And then we can basically say this is a file. So basically what we want to do is add some features to this input to configure it with React so that it can actually upload the video. So we'll do that like this. We'll just do like this and boom. All right, so input is a video title, text, form control is for Bootstrap, and then the placeholder for title. So see that here, and then boom, there we go. So video title. So that's going to be for the title of the video, okay? And then we also want an input for the video file, okay? So we can do that right here. So we can take this out and say boom. All right, so input, this type is file. And this will basically allow us to upload a file. And then we'll go back to the thing here. Boom, there we go. All right. So you can see share video. We can choose the file, add the title, click upload. So this will be the basic user interface for doing that. So let's go ahead and finish this up. Sorry, let me go to the text editor here. All right. So when we upload this video, it's going to be a two-step process, okay? So what we're going to do, remember, is we're going to basically allow them to talk to the to ipfs whenever they upload the video. So it'd be two steps. We'll catch the video from ipfs. We'll catch the video from the web browser. We'll put it on ipfs. Okay. ipfs will return this hash. Okay. And then we'll save that to the blockchain. Okay. With a smart contract here. So let me show you how that works. We'll go back to this, and what we want to do is basically have this function called props capture file. Okay. And when we capture this file, it's going to put it on ipfs for us. Okay. So I'll show you what that looks like. Go back to this app.js file and say capture file. All right. So what this capture file is going to do is basically convert the file to a buffer. All right. And then it's going to get it ready to be processed and put on ipfs. So capture file will look like this. We're gonna film this function, but let's go ahead and pass it down to the component. So we'll say we'll put capture file here. All right, capture file, and then inside of here, we've got this props.capture file here. So basically, whenever this is changed, whenever we actually upload a file, it'll process it and convert it to the format that we need for ipfs. All right. So essentially what we want to do is convert this into a buffer object for the upload like this. Basically, we'll just do this. So what we do is prevent the default behavior, and then we capture the file, and then we convert it to a buffer like this, and then we add it to the state like this. Okay. So all this does is pre-process the file. Don't worry if you don't understand everything inside this code block right here. Basically, it's just saying prepare the file for upload to ipfs. All right. So I'm going to save that, and then we can go ahead and see that in action. So I'll go back to my page here, click refresh. I'm going to click this choose file button. I'll do it offline so I don't reveal all my files on my computer. But I'll choose a video here. All right, so I save that and bring it back onto the page here. And I've taken a video, and you can see the output here. So this buffer is just the file format that we need in our web browser so we can process the file and put it on ipfs. You can see that logged to the console here. And that's exactly what we did in this console logging statement right here, okay? All right, so the next thing we want to do is actually take the title as well. Take the title and then take the file and upload that information to the blockchain. So inside of this, inside of the file name here, we'll also add an onChange handler to capture the file. Or say, this video title, basically, or not onChange, but we'll do a ref. I'll show you what I mean by that. So inside here, after title, we'll say ref. All right, ref with input, and then it's going to just be the name here. So what we want to do is basically capture the submit event where this form is submitted and fill this part out right here. So this is where we upload the video to ipfs. So I'll show you how that works. Basically, we'll just replace this and say, event prevent default. Say title equals this dot video title dot value, which we changed here. And then we want to upload the video to ipfs with this special function that we pass in called upload video, which I'll show you how to do that now. So you see this upload video right here. Boom. This is what we're going to change. Okay. So we'll go ahead and pass it down to the function like this. Go inside the app.js components. Capture file. Let's do this. Upload video. Boom. This upload video. Right here. So we pass in the title. And then first thing we're going to do is, tell it to the console, boom, submitting file to ipfs. So we can just test that out and just see if it works. So I'm going to upload my video off screen. All right. I'll say, boom. And then I'll give it a title. Oops, sorry. I'll give it a title that just says, look at this cat video. Click upload. And then boom, you can see submitting file to ipfs. So that's wired up. Okay. So now inside of here, we want to actually do that. So here's the secret sauce. Here's how we add the file to ipfs. First of all, we need a connection to ipfs, which we already have saved inside of our file here at the top. Here's our ipfs client. Okay. So ipfs client is just a library in JavaScript. So we've installed it with npm, and we can see our ipfs connection here. So we say ipfs equals ipfs client, pass in the host for Infura, the port, and then the HTTPS protocol. Okay. So now that we have the connection, we can add new files to ipfs like this. We basically just say ipfs add. All right. It just has a function that just passes in the file and then callback. It's pretty simple. Okay, that's all it is. ipfs add, we pass it in the file and the callback. Now, this file needs to be in a special format, which we already did in this step, capture file, okay? And we saved it to the state. So we can just say this.state.buffer. All right, we converted it to a buffer object already. And then we pass in a callback function to execute some more code whenever it's been put on ipfs. Okay, so that's going to look like this. Okay, and then once that's done, we can wait for that to finish. And then what we want to do inside of here is put on blockchain. All right, because remember, it's a two-step process. It is, let me just move this. We have to pass the file to ipfs, we get the hash back, and then we put it inside the smart contract to actually save it to the blockchain. It acts like our database in this case, okay? So, looks like we got a little bit of an issue here. Let's go back and see what the error is. So let's just fix that. All right, let me just, sorry, I forgot to do the closing parenthesis. Save that. All right, sorry. Okay, boom, works. All right. So next, we want to do some basic error handling. Let's just do it once. Okay. And then if it has an error, we'll just return the error. Okay. So let's just load it. Let's just post it to ipfs before we save it to the blockchain. Let's do that. Then go here, and then I'll do it off screen again. I'll upload the cat video. Say, look at this cat video. All right, and I'll click upload. Submitting file to ipfs. And here we go. Boom, here's the result. Awesome. So here's the actual ipfs hash. And, we can go back to our example here and look at this. And I can actually, edit this text and replace the hash. Boom. All right, take off the quotation marks, copy this, and then go to my browser here. This off screen, and there we go. Awesome. There's the video that I just uploaded. Boom. Very cool. So we are cooking with gas. Now that we have the file uploaded to ipfs, we're going to save it to the smart contract on the blockchain, and we'll do that like this. So we'll put on blockchain here, And it's pretty easy. We'll first of all set the state loading to true. And then we'll say this.state.dVideo, it's the smart contract, methods, upload video. All right. And so that's the exact function that we created when we created the smart contract. So look at this. Sorry, source contracts, dVideo. You know, this upload video function, we're going to pass in the video hash and the title. So the video hash is going to be results 0. Okay, because that's the result that comes back from ipfs. And then it's an array. We should get the first item out of it. It's a hash. And then the title that's passed in from the function call here. Okay. And then, yeah, there we go. So now inside Web3, of course, we don't want to, we can't, this won't actually call the function. We have to say send. So here you go. You know, my method call is when you're reading data, but when you're writing data, you have to say send at the end, because this actually creates a transaction on the blockchain, and you have to tell it who is sending this. So we say .send, and we're going to pass in the account. So we say, oops, sorry. So we say from this.state.account. Okay. So that's the account that we're connecting to with MetaMask. All right. And then after that, basically, whenever we get a transaction hash back, we want to stop loading the app. So say, you know, on transaction hash here. Oops, sorry. My mouse has gone crazy. After the transaction hash has come back, we basically want to set the loading state to false like this. So this set state loading false. Boom. Awesome. So that should work. And whenever we upload it, we should see a MetaMask confirmation pop up. And yeah, let's give it a shot. So we'll go here. I'm gonna choose the file off screen again. I'll choose that cat video. I'll open it. All right, so I got the file uploaded, and then I'll do a title. Look at this cat video. Click upload. You should see a MetaMask confirmation pop up. Yep, boom, there we go. All right, so we'll sign it. We'll pay the gas fee with cryptocurrency. Click confirm. And let's see, quick refresh. All right, I think it worked. Yeah, it worked. So we don't see anything on the page yet. That's okay, but it's, you know, it's on the blockchain. If you really wanted to, you could boot up the console and verify that for yourself. But I'm going to keep coding this out and list the videos onto the page so we can see that video we just uploaded. All right. So let's go back to the app here. And let's do this. Go to the main component, and we can see we want to show the selected video at the top of the file. So let's do it like this. Sorry, let's see here. Let me find the best way to do this. Inside the main component, let's change, yeah, let's change the current hash. So yeah. Sorry, I'm trying to think here. Yeah. We need to change some of this here inside the app.js component, okay? So basically what we want to do is we have the current video listed here. So basically we said set state current hash is the latest hash because we sorted the videos, you know, by the most recent. So we got the latest video, and we want to show that on the YouTube player. Okay. So let's pass in the current hash like this. Here we'll say current hash. Okay. And we'll go into this dVideo, sorry, the main component here. And then we'll render that video out on the page. So we'll just add a video element here. We'll just remove this and do like this. Boom. So here's the video. So the source will just be the ipfs URL. It's the same every time. And then we just put in the current hash like this. Okay, so this props.current hash, which we saved here. All right, this state current hash, which we set here. All right, boom. So now let's go back here, and let's, we got an issue here. So okay, let's just fix that. Inside the main components, yeah, I see what's going on here. Basically, we need to do a closing video tag. My fault, everybody. All right, now that should work. All right, boom, there we go. We can see our video here. So I can click play, and there's our cat video. I'm gonna go ahead and close the console here so we can see our interface. All right, so now we're getting somewhere. All right, so we can upload a video, we can choose a video, and now we want to do is list all the videos out here on the side of the page. Okay, so I'm gonna do that like this. I'm gonna go back into the application. All right, and then we're going to also show the video title, so we can go ahead and change that here. Boom. And then here we go. Let's see here. Oh, we haven't passed in the current title, so we got to do that here. So just below current hash, we want to do current title. All right. And look at this cat video, you know. Boom. Awesome. Very cool. All right. Awesome. Boom. So now let's list the videos in the sidebar. So we can get, we can list all the videos like this. We'll go in here and we'll wire up this right here. So we can say, we're going to use we're going to map over them just below the form here. Basically, we'll just do it like this. So take everything after the form and then replace it like this. Boom. So this props video, we'll map over it and we'll list all the videos here. All right. So it might blow up on us. We're going to find out. All right. So we don't have any videos inside there, so it doesn't work. So inside of app.js, we need to pass the videos down. We'll do that like this. We'll say videos at the very top. All right. And then boom, there we go. Here's our videos on the side. Okay. So now what we want to do is actually be able to change the videos. So we need to basically add this function here. So what we're going to do is just set the state to the current video whenever we click on it. All right. So change the video, this state current hash, and we want to pass that function down to the main component like this, capture file, capture change video, and then inside of here, we should be able to change it. So look at this cat video, and click on this, and it changes it. Now we already have that, so let's go ahead and add a second video. I'm going to do that off screen. Click a second cat video like this. Click this one. All right, so I have a second. And we'll say, you know, all cute kitty. Click upload. Wait, come to ipfs. Then we'll have a MetaMask confirmation come back. Click confirm. All right, and then boom, there we go. So all cute kitty, and look at this cat video. All right, so boom, there we go. We can change it. All right, and it shows the latest one, and now we can swap between videos here. So I can go ahead and add another one to go ahead and populate our feed here with a nice, rich timeline. So we'll say kitty loves to play. Click upload. All right, and confirm. And then boom, there we go. Awesome. So now we can see, a sidebar just like YouTube over here with our videos. We can upload them and then change the videos on the player. All right. So I think we're getting pretty close to finish here. Let me just kind of browse over this, make sure I didn't miss anything. Let's look at the main file. I think all that's good. Let's see here. Yeah, that's it, everybody. So this is a complete decentralized YouTube clone on the blockchain. All right. So congratulations. You know, it's the first time building a blockchain application. You've come a long way. You've used the interplanetary file system. You've used Ethereum. You created smart contracts. You created an unstoppable, YouTube clone that can't be censored because, hey, now that these files are on ipfs, now they're on the blockchain, no one can take them down and they can't change. All right. So congratulations. If you got stuck anywhere, of course, you can compare your code with the final code solution in the GitHub repository. As always, if you like this video, smash the like button down below for the YouTube algorithm, subscribe to this channel, share this video around. That really helps them get found so that more people can learn about blockchain. And if you like this video and you want to, take the next step, build your own real world blockchain application step by step from start to finish, way beyond the depth of this particular tutorial. Build a real world project so you can, land a high paying job, become a freelancer, whatever. I can show you how to do that step by step over at dappuniversity.com/bootcamp, right? Just click the link here below, sign up today, and I'll show you how to do that. So that's all I've got. And until next time, thanks for watching Dapp University.